Hello students! How are you? Are you happy, sad, or feeling determined as of the moment? Let me know what you feel in our comment section or group chat. Well, you must be happy because we are already in the last 2 weeks of school year 2021-2022. Congratulations, you have come to this point in your student life. Well, we're still in week 8, so let's make this week a week to learn new things. Still with you is your science teacher, Teacher April. These are the materials that you should have with you as you watch this video. First, you should have your self-learning module 8.1, Generation, Transmission, and Distribution of Electricity. You should have also your pen or pencil and paper. And lastly, you should have with you your activity sheet. Okay, so let me remind you with our virtual class rules. Rule number 1, find a comfortable space to study. A comfortable space will make you focused and productive. Rule number 2, watch the video intently. This will help you understand the lesson properly. Rule number 3, participate actively in class. And last one, smile and enjoy learning. Are you familiar with this game, guys? Or have you ever tried the filter trend in Instagram or TikTok, which is the guess the celebrity or guess the word using icons or emojis? If yes, well, maybe this will be an easier task for you. But if not, this will be your practice ground for you to easily play the trend later on. The game titled Guess the Word. You are going to sound out the clues to guess the word related to electricity. You may send your answer in our group chat or in the comment section. Are you ready? Okay, let's go. So let's have the first guess the word. Okay, what's the answer? Okay, the correct answer is turbine. Very good. Okay, let's go on to second word. What do you think is the answer? You are right. It is source. Let's have the third word. This one is a little bit hard. Very good. It is generator. And lastly, what do you think is the answer? Yes, it is inverter. Tama yan. Turbine, source, generator, and inverter are related to our topic, which is embedded to the milk. Explain how electrical energy is generated, transmitted, and distributed. Specifically, the following objectives. Identify the steps in generating electrical energy in power plants. Second, explain the steps in the transmission and distribution of electrical energy from the power plants to the households. Third, calculate the energy consumption and energy cost in everyday use. And lastly, show the importance of conserving electrical energy. Electricity is vital to mankind in this modern age. Industries use it to make different products that are beneficial to man. Electricity has been an integral part of our lives since the time it was discovered. Most of the comforts we enjoy nowadays employ the use of electricity. For the next activity titled What's My Reaction, you are going to watch a video about life without electricity. Then, you're going to share your reactions or reflections about the video that is shown. You're going to send the answer using the Padlet link below, or you could pause this video and scan the QR code. Can you live such a life? Why or why not? We enjoy the benefits of electricity in our homes through our electrical appliances, gadgets, and others. As you watch this video while charging your devices or plug in your electric fan, do you ever imagine how electricity reaches you from where it came from? With this activity 3E, observe, let's find out how electricity may produce through PET Colorado simulation. Okay, so this is the guide questions that you are going to answer later on. The first one, which energy sources can cause the turbine to spin and generate electrical energy? Second, which energy sources cause the solar panels to generate electrical energy? And third one, what happens to the amount of electrical energy that is generated when the faucet is on high or low? Okay, so you're going to answer this one later on after the video of simulation. You could go back to this one or pause for 5 minutes to answer and send your answer to the link given or to the group chat. Okay, so here is the simulation video. Okay, so pause this video for a moment for 5 minutes and answer the 3 questions. Send it to our group chat. You may share it to our group chat or to our comment section. How does electricity reach you from where it came from? Do you know? Okay, so that's the question we're going to find out as we go on to our discussion. There are 3 main processes in providing electricity. First one is generation, transmission, and then distribution. Let's talk first about generation. Generation. Electricity must be generated from an energy source, which is the power plant or power station. There are different types of power plants depending on the sources of energy. From the simulation, what do you think are the different sources of energy? Okay, so you are right. So from a running water, from the sun, from a wind, and from the heat coming from the earth. Or we have the hydrothermal or hydroelectric, the solar panels, the wind energy, and the geothermal energy. Aside from that, the burning of fossil fuels, either from oil, coal, or natural gases, can generate 65% of electric power. And for today, or as of the moment, we are using fossil fuels to generate electricity in our homes. Okay, so let's have a little self-check. What type of resources are these? Is it renewable or non-renewable resources? This is a topic coming from grade 7. So let's just have a review. What type of resources are these? Okay, so you are right. So hydroelectric, solar panel, with solar energy, wind energy, and geothermal energy are examples of renewable resources. Okay, so we have the Philippine Energy Plan 2018-2040. So the Philippine Energy Plan 2018 to 2040 aims to increase the production of clean and indigenous energy resources for power generation to make our country self-reliant and less dependent on imported fuel. Hydroelectric power was among the first indigenous sources, and under Executive Order Number 30, the Department of Energy reported that there are several large-scale power projects that could receive certification as being one energy projects. Here are some: the Wawa Pump Storage and also the 500 megawatt Kibungan Badeo. Oh, familiar ka ba kadetoy? Okay, so familiar kayo ba kadetoy aladawan? May saday tuy kadagiti ipagtangtang city probinsya tayo nga Ilocos Norte. The Bangi and Burgos Wind Mill or Wind Farm. Not just for some tourist destination but also a reliable source of energy that is continuously developing until now. So we have this here in Ilocos. How about this one? Are you familiar? Okay, so aside from the windmills, did you know that we have also the Burgos Solar Panel Farm? It is because on that area, there are a lot of, or there is a strong wind and also very bright or a sunny day, which could be a source of energy. Okay, so how electricity produced from these different sources? Okay, so we have what they call the generator. So electricity can be generated through a variety of sources. These sources supply the energy necessary to turn large turbines which are connected to a device called the generator. From this simulation, what does the generator's role in the production of electricity? Okay, so if you still remember, when the time I opened this faucet, what happened to this generator or the turbine here in the generator? What happens to the mechanical energy coming from the running water? What happens? Okay, so it turns these turbines that converted into electrical energy that makes this LEC to move. Okay, so inside the generator, there is a magnet. Okay, so it is made possible by the interaction between the changing magnetic field and the conductor inside the generator assembly. A magnet at rest or a conductor at rest cannot produce an electric current. Current is induced via moving the magnet or the conductor. Okay, so kanina, nung wala ng tubig na lumabas sa faucet, hindi na gumalaw yung turbine, hindi na rin nakapag-produce ng electrical energy to move the LEC or to turn on the bulb. Okay, so that is the work of generator. Okay, so this diagram shows a dam. Okay, so how does dam generate an electricity? Okay, so let's find out. So we have the different parts of this. We have this head pond, intake, where the running water could move, the generator, the powerhouse, the turbine. We have also the penstock, the draft tube, and the toll race. We have also here the transformer. So in kinetic power plants, like hydroelectric power plants, the falling water or the running water turns the turbine. Okay, so this is the running water that turns the turbine. So in this schematic diagram of how hydroelectric plants produce electricity, water acquires potential energy as it's stored behind the dam. This potential energy is converted into kinetic energy as the water flows through special channels that lead to several turbines. The water rotates the blades of these turbines, which then turn large magnets or coils of a generator. The generator transforms kinetic energy of its coils or magnets into electrical energy. The water then continues its flow through the river for recycling. Okay, so that is how the hydroelectric power plant converts electricity. So we have also the dry steam power plant, or more commonly known as thermal power plants. Okay, so for thermal power plants, it operates by heating water in a boiler until it becomes superheated steam at a high or at a very high temperature. So this red arrow represents a very high temperature steam. So the steam is produced by either burning oil, coal, natural gas, or solid waste biomass. The superheated steam turns a turbine. So as you can see, this red arrow here are the superheated steam, and it turns the turbine here and moves to a condenser where it is converted to a water that can be reused. So this one is the blue arrow here is the water that can be reused. So this one shows the process and their accompanying energy transformation of a dry steam power plant. Okay, so there is a question here. From the simulation, how will the light energy coming from the sun be converted as electricity? Okay, any idea? Okay, so you are right. So solar energy can be directly transformed into electrical energy through the use of photovoltaic or solar cells. Nakita nyo kanina dun sa simulation, nung una ginamit natin ang generator, but there is no conversion of light energy to electrical energy. That's why we change it to a solar panel or solar cells, or what you call photovoltaic, and that is the time when the solar or the light energy converts into an electrical energy. Okay, so we are done with the generation. Let's go on to transmission and distribution. Okay, so transmission, the second one is transformer step-up voltage for transmission. So after generating electricity in the power plant, it then flows through large wires connected to a step-up transformer. Step-up transformer raises the voltage as high as 756 kilovolt so it can travel long distances. The current generated from power plant is sent through transformers to increase the voltage. A transformer that is designed to increase the voltage is called step-up transformer. Okay, so after that one, transmission lines carry electricity over long distances. So the transmission is the movement of electricity from a generating site to a substation where it is distributed to homes. Transmission lines are constructed overhead electrical towers or underground. They carry electricity at high voltage from the power to a substation. Then, electricity were in the neighborhood transformer step-down voltage. A step-down transformer lowers voltage in distribution lines. So voltage is lowered in preparation for distribution to households. Distribution substation uses a smaller step-down transformer to decrease the voltage so that it can be sent through distribution poles. So that is the fourth steps in your distributing electricity. Okay, so the fifth one is the distribution lines carry electricity to houses. Okay, so electricity travels through small transmission lines called the distribution lines towards your home. Are you familiar with this one? Have you seen like this in your neighbor? Okay, so those are your distribution lines. So they carry electricity to houses. Okay, so the next one is the pole transformer step-down electricity before it enters home. So the pole step-down transformer further reduces the voltage before it enters our houses. So a small transformer mounted on a distribution pole further reduces the voltage to 110 to 220 volts. This is done to ensure that the only 220 volt goes into our homes. And have you seen like this? This is what you call service drop wire. Okay, service drop wire provides the path for the power from the distribution pole to our houses. And how about this one? Do you have like this in your home? Okay, so this is your fuse box, or the modern houses uses this control panel electricity board. So in the house, the control panel distributes power through wires in the walls and through a meter that measures the amount of electrical energy used. Okay, so that is your control panel. And then, if we plug in our appliances, we complete a circuit powered by the power plant, thereby making the lights and appliances work. Okay, so kung naka-open yung mga fuse boxes natin or yung circuit board, and then we plug in our appliances, it will surely make our appliances work. So that is how electricity reaches our home. Okay, so we have already tackled how electricity reaches our home. Can you try to give a hypothesis to why San Marcelino experiences brownout these days? What do you think is the main problem? Is it on the part of fuse box or control panel, or the transmission lines, or the distribution lines? What do you think? Can you give a hypothesis? You may comment your answer to our chat box or the comment section. Okay, so let's move on. Can you ask your parents how much did they pay for your electric bill last month, or if there is an electric bill already for this month, for the month of June? How much? Okay, so now we're going to learn how to compute energy consumed and how to compute energy cost for this section. Okay, so to get the total energy consumed, this is the formula. E is equal to P times T, where E is equal to the energy used, and it is in kilowatt hour. P is equal to power. T is equal to time. It's either second or hour. The unit of measurement for energy used is a kilowatt hour, which is 1 kilowatt of power for a period of 1 hour. Okay, so let's have a activity, which is activity I solve. Activity I solve. So first one, a phone consumes energy of 500 watts of power if you charge it for 2 hours a day. Calculate energy consumption of the phone, charging of phones in a day. How much will you pay if the energy cost of electricity is 8.50 per kilowatt hour? So what are the given? We have the power is equal to 500 watts and time is equal to 2 hours. What are we going to find? The electricity consumed and the cost. Our formula for electricity consumed is E is equal to P times T. Okay? So because of the our power is still in watts, we're going to convert 500 watts to kilowatt. Okay, so remember that 1 kilowatt is equal to 1000 watt. Okay, so 500 watt times 1 kilowatt divided by 1000 watt is equal to 0.50 kilowatt. Okay, and then we can now use our formula, which is E is equal to P times T, wherein 0.50 kilowatt is our power now times 2 hours. So what's the answer? That is 1 kilowatt hour. So you consume 1 kilowatt hour per day. So still on the same problem, how much will you pay for it per day? Okay, so cost is equal to energy consumption times cost of electricity per kilowatt hour. So cost is equal to 1 kilowatt hour times 8.32, equivalent to 8.32 pesos per day. So what if you have done that for 31 days or 1 month? How much will you pay? Just only for phone, okay? So 8.32 times 31 days, that is equal to 257.92 only for one device or one appliance. Okay? So, what's the challenge, my dear students? Okay, so conserve energy. Why do we need to conserve energy? This topic is also related to conserving our environment, conserving our Mother Earth. Why? The generation of electricity and global warming are interrelated. Do you still remember what I have told a while back? That 65% of our electric current came from burning of fuels. And burning of fuels releases carbon dioxide, toxins, fumes, and heat into the environment. So global warming affects the generations, transmissions, and distribution of electricity to consumers. So it raises the demand for electricity and creates more power losses because of the thermal expansion of transmission lines. It also diminishes the supply of the alternative power or fuels. So my challenge to you, my dear student, is to conserve energy. Not only for you, my dear student, the whole family. So share it to your parents how to conserve energy. Okay, so that's the end for our discussion part. So now may I ask you, student, what have you realized in studying the processes involved in the production and distribution of electricity? How this topic help you in your everyday living? You could share your answer, share your reactions or reflections in our comment section. Okay, so for our evaluation, are you familiar with this game show, Celebrity Bluff? Okay, so you're just going to identify if the statement, whether it is a fact or a bluff. Are you ready? You could pause the video, and write your answer to a clean sheet of paper or in your activity sheet. Okay? So, first question. Power plant generates electricity. Power plant generates electricity. Is it a fact or a bluff? The answer? It's a fact. Power plant generates electricity. Okay, second, step-up transformers reduce the output voltage. The step-up transformers reduce the output voltage. Is it a fact or a bluff? What's your answer? It's a bluff. Okay. So third one, I should say, transmission lines transport high voltage electricity over long distances. Transmission lines transport high voltage electricity over long distances. Is it a fact or a bluff? What's your final answer? It is a fact. Okay, so the transmission lines transport high voltage electricity over long distances. Okay, next, distribution lines carry electricity at a lower voltage. I repeat, distribution lines carry electricity at a lower voltage. Is it a fact or a bluff? It's a fact. Okay, so next one, neighborhood transformer lowers the voltage to an amount that can be safely used by appliances at home. Neighborhood transformer lowers the voltage to an amount that can be safely used by appliances at home. Is it a fact or a bluff? What's the answer? It's a fact. Very good. Okay, next, pole step-up transformers further reduce the voltage before it enters your home. Pole step-up transformers further reduce the voltage before it enters your home. Is it a fact or a bluff? What's your answer? It's a fact. Okay. Next, electric meter measures the amount of electrical energy used. Electric meter measures the amount of electrical energy used. Fact or a bluff? The answer? Very good. It is a fact. Okay. In the house control panel, distributes power through wires on the wall. In the house, the control panel distributes power through wires on the wall. Is it a fact or a bluff? The correct answer? It's a fact. Okay, let's have this. A big transformer is mounted on a distribution pole. A big transformer is mounted on a distribution pole. Is it a fact or a bluff? The answer? It's a bluff. Okay, and last one. The distribution substation uses big transformer to step up voltage. The distribution substation uses big transformer to step up voltage. Is it a fact or a bluff? The answer? It's a bluff. Okay, so for your performance task, this one. So in celebration of the Energy Conservation Week, San Marcelino National High School plans to collaborate with the local office of the Department of Energy to organize a campaign on conserving energy. As a grade 9 who has a knowledge about the generation, transmission, and distribution of electricity, you are tasked to prepare a 2 to 3 minute video or digital infographic or a handwritten flyer or a short story writing that will explain to the people in your area the need to conserve energy by emphasizing how much resources and work are involved in generating electricity and distributing it to homes, and how this electricity reaches their homes. The success of your campaign will be evaluated based on the concept, content, and organization. You may use your mother tongue language in order to share it effectively with your neighbors. Okay, so here are the rubric. So you're going to have the concept 40%, content 40%, organization 20%. Okay, so that is your performance task. If you have some questions regarding our topic, don't hesitate to message me. Once again, I am your teacher April, and this is Sci-Fun Learning, where you can learn and have fun. Good day, everyone.